Hello everyone and welcome to Jerome's Learning. So for today's video, we are going to talk about significant figures. When making a measurement, there is a limit to the accuracy of the reported value. Both the reporter and the reader must follow the conventions of significant figures when handling measured quantities. There are simple rules which are used to tell how many significant figures are contained in a value.
So here are the rules for significant figures. Rule number 1. All non-zero numbers are significant. So for example, this number 33.2. So it has 3 significant figures because all of the digits present are non-zero. Rule number 2. Zeros between 2 non-zero digits are significant. For example, 2051. So it has 4 significant figures because the 0 is between 2 and 5. Another example is 308. So it has 3 significant figures since 0 is between 3 and 8. Rule number 3. Leading zeros are not significant. They are nothing more than placeholders. So for example, 0.54 has only 2 significant figures. Another example is 0.0032. It has also 2 significant figures. So all of the zeros are leading. So it is just a placeholder. So therefore, it has only 2 significant figures, the 3 and 2. Rule number 4. Trailing zeros to the right of the decimal are significant. So in this example, there are 4 significant figures. So 92.00 is different from 92 alone. So it is important to understand that 0 does not mean nothing. 0 denotes actual information, just like any other number. So you cannot tag on zeros that aren't certain to belong there. Rule number 5. Trailing zeros in a whole number with decimal shown are significant. Placing a decimal at the end of a number is usually not done. But by convention, however, this decimal indicates a significant 0. So this example 540. This indicates that the trailing 0 is significant. So therefore, it has 3 significant figures in this value. Rule number 6. Trailing zeros in a whole number with no decimal shown are not significant. So writing just 540 indicates that the 0 is not significant. And there are only 2 significant figures in this value. Rule number 7. Exact numbers have an infinite number of significant figures. So this rule applies to numbers that are definitions. So for example, we have 1 meter. It could be equal to 1.00 meters, 1.00 meters, and also equal to 1.0000 meters, and etc. Rule number 8. So for a number in scientific notation, n times 10 to the power of x, so all digits comprising n are significant by the first 6 rules. So, for instance, 10 and x are not significant. So, for example, we have 5.4 times 10 to the power of 3. So, in this example, only 5.4 is significant. So, this 10 and the exponent 3 is not significant. So, in this figure, we only have 2 significant figures.
So that's all for this video. Thank you for watching and I hope you learned something. Keep updated for more tutorial video.